Welcome. In this lecture, I want to go through just a few more limit properties. So this one has to do with roots. So let's go ahead and get started with this. So the first one is property 10. Okay, and property 10 is that if I take the limit as x approaches a of, and actually here, let me kind of first set up here. We're going to suppose for this property, we want to suppose that, so suppose we have that. So what are our suppositions for this property, which is that n is a positive integer. So n is a positive integer. And our other kind of supposition is that a is going to be, so, and we have that a is going to be greater than 0 if n is even. So a is greater than 0 if we know that n is even. Okay. Okay, so that's kind of the setup, and then we have that the limit as x approaches a of the nth root, so we have the nth root here, of x, right, of this x, right, what do we get out? So maybe I'll even put the parentheses here to kind of emphasize that, that what we get out is going to be the nth root, so that same nth root of this value a here, so of the value a. And then let's go ahead and do an example. So here's my example, which is that I'm going to have, so in this example, I'm going to have the limit as x approaches, then why not do something like pi squared? Why not? Of x to the 1/4. This is, what's going to do is, this is our entire function, so let's just write that here. This is what we're taking the limit of. And then if we look at that, so what do we get? If we look at that, that this is going to equal the limit as x approaches. So why does this fall under the circumstances? This is equal to this limit. And then another way to write that is that this is actually the 4th root of x. Okay, so this is actually the 4th root of x here. Okay, so just using this property, now you can kind of see how these are exactly the same and correspond. So I can get here that this is equal to the 4th root of, and then I can put pi squared in here. And then let's just kind of simplify this down a little bit. So this is good practice at this, which is part of why I'm doing this. So we're doing pi squared. A 4th root is the same thing as 1/4. Okay. Then what happens if you take a power to a power? You're going to multiply them, so you get 2 times 1/4, right? Which is just pi to the 1/2, or the square root of pi. Okay. Great. Now for so all I did there, right, and there was an extra step in here, right, which is I had to remember that the 1/4 power is the same thing as a 4th root. And then I could just plug this right in, right, for x. That's kind of what the property tells me. And then I want to be able to reduce this down. So when I want to put this back to be, because this is a power like that, it's going to help to put that to be a power like that. It's a 4th root, so that's going to be 1/4. So now I have pi, but these are a power to a power, so you multiply them. So I get pi, and then 2 times 1/4, so I get pi to the 1/2, because 2 times 1/4 is 1/2, which is the same thing as the square root of pi. Okay, here's the next property. So this was the first property, was up here. Well, that suppose actually goes there. And then we have, oh, by the way, to work out here, we have, in this correspondence, this is n equals 4, and a equals pi squared, if you're trying to work that out. It's useful. Okay, let's do the next one. So we have, this is property 11, which is going to be that this is going to work for more general functions. Okay, so we have the limit as x approaches a of the nth root of f of x. Okay, and this is going to equal, and so it's going to work kind of, well, it is a generalization of that, but let's just go ahead and write it. So this is actually going to equal, what I'm able to do here is I'm able to take the nth root to the outside, which is kind of the same thing as I'm doing there, actually. So I'm going to be able to take this nth root out, so I'm going to take the nth root of the limit. So let's go ahead and do that. Of the limit as x approaches a of the function, right? So I'm kind of able to pull out the root, which is nice. Okay, where here we have, so kind of our setup, like that one had a setup up there, is that we have, so this is where, so what do we need to be true? Which is that n is a positive integer. So n is a positive integer, and we're going to have that, the other thing that we have going on here is that we need that the limit, this limit as x approaches a of f of x has to be greater than 0 if n is even. Right, and this actually kind of makes sense because you can't take, right, you can't take an even root of a negative value, right? You can't take the square root of -3, right, or something like that. That's kind of the situation that this is dealing with. Okay, so this is the other property. I guess actually I'll put the where in it too. And then we'll go through an example. I'm going to go through an example that's going to kind of emphasize something else that we've been looked at when we looked at limits. I guess I am going to kind of say, this actually goes with this property, so it should be in its box. There. It's kind of like a tagged on box, but I think you understand what I mean. Okay, so to do this example, let's recall how I think about the natural logarithm. So recall how to think about the natural logarithm. Okay, so this is how I think about the natural logarithm. I went over this when we were talking about limits. Okay, so here's kind of the key point, which is that saying that, and these colors kind of don't correspond to any other colors, I just want to be able to use them like this. So if I want to say that the natural log of x equals y, like what does that correspond to in terms of the exponential function, which is the function that we tend to understand a lot better. And it tells me that e to the y is going to equal x. Okay, so these two things are like equivalent statements. They correspond to each other. So that tells me then, for example, when I say that the natural log of 1 equals 0, this actually corresponds to the statement, which is one that we understand a lot better. So if we were trying to figure this out, we could use the fact that e to the 0 actually equals 1. Okay, because anything to the 0 equals 1. So you could have used that to kind of figure out what's going on here. And then also the natural log of e equals 1. One could think of as this coming from, because this is an equivalent statement to the statement where we have that e to the 1 equals e. Right? Anything to the 1 equals itself. Okay, so these are kind of useful when you're trying to think about natural logarithms, to kind of think through what its relationship with the exponential function is going to tell you, because you're often going to need to use that. So Here we go. So let's look at an example for this property. So example for this property. Okay, what I want to do for this one is I want to try to figure out what is the limit as x approaches e of the square root of the natural log of x. That could be tricky, like I don't, how do you figure that out? Okay, so this is what you can do. Well, this is equal to, so what is that equal to? This is equal to the limit as, and then we're going to go x approaches e of, well, the square root is actually the same thing as, and this is one of the things I wanted to emphasize here. Saying the square root is like having a 2 there, okay, of the natural log of x. And then we can bring this, right, now we can bring the limit inside by this over here. So this is going to equal, and we do need to check here. 2 is a positive integer, but the natural log, the 2 is a positive integer, but the natural log at e is going to be positive, so we're good. Okay. So we're going to have the square root on the outside, right, and then we're going to take on the inside the limit as x approaches e of this natural log of x. Okay, well now we can just plug e into here. Like you could look at the graph to see, but this is just a continuous function that's defined there. So you can just plug it in, okay? So this is going to equal the square root of the natural log of e. Okay, so what is that? Well, the natural log of e, you can kind of check from up here is 1, right? And if you were trying to figure that out, you could remember, how do I get out e? What power? I need to have 1 there. Okay, so this is just equal to the square root of 1. What is the square root of 1? That's just 1. And we're done. Okay. So these all kind of used, I mean, these are just 2 new properties. They basically tell you can pull out the root. And I specifically did this with a natural logarithm to help get you more used to the natural logarithm and how it works. And a lot of it is just with the pairing with the exponential function. But we were able to pull out this square. And then another key thing to remember, so what are some other key things I tried to highlight in the examples? One is that if I'm taking the square root, that's actually the same thing as having a 2 there in the root. Okay. The other thing, so I've told you 2 things I was trying to give you practice with in this example. Another one is going back and forth between the power written as an exponent like that and then written as a root like this. And the fact that when you take something to a power, you can multiply those powers. Okay, so all those things I was just trying to give you a little bit of extra practice with, because I know that these are things that a lot of times somehow we just kind of miss them. And so the more you see them, the more likely it is that it'll stick. Or you can ask yourself, wait, what was this? I missed this. Why? And you can kind of go back through and know that it's something you should look at it again. But part of that is just giving you more practice so that you know that. Okay, so hope that made some sense. And I will see you in the next lecture.